Summer 2020. So in our first lecture, we will learn the three-dimensional coordinate system. We normally know the two-dimensional coordinate system where we have x-axis and y-axis, and this is called the xy plane. Now in three-dimensional coordinate system, we have x-axis, y-axis and also z-axis. You can think corner of your room. So this x-axis is one direction, this y-axis in another direction, and this one is height of this room, of your room, and this is the floor, your room floor. Now this one is called the xy plane where z equals to 0, and this is called the xz plane where y equals to 0, and this one is called yz plane where x equals to 0. So in our example, the xy plane is this one. Okay, xy plane is this one where z equals to 0, and xz plane is this one where y equals to 0. Similarly, the yz plane. Now to find the distance between 2 points in the three-dimensional coordinate system, suppose we have 2 points P and Q where the coordinate of P is x1, y1, z1 and coordinate of Q is x2, y2, z2. Now if we consider the two-dimensional system, suppose we have 2 points P and Q and the coordinate of P is x1, y1 and the coordinate of Q is x2, y2. Then we normally know the distance between these 2 points PQ is defined as this way. That means square root of x1 minus x2 whole square plus y1 minus y2 whole square. Similarly, in three-dimensional coordinate system, the distance is defined as square root of x2 minus x1 whole square, or you can write x1 minus x2 whole square, it doesn't matter, plus y2 minus y1 whole square plus z2 minus z1 whole square. So there is a similarity between the formula of three-dimensional system and two-dimensional coordinate system. Now to find the midpoint of this straight line in 3 dimension, the formula is x1 plus x2 divided by 2 plus y1 plus y2 divided by 2 comma z1 plus z2 divided by 2. You know, in two-dimensional coordinate system, if we have the straight line PQ, then this is the midpoint, and its formula was x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. So there is a similarity between two-dimensional and three-dimension. Now in two-dimension, we learn the equation of a circle center at AB with radius r is x minus a whole square plus y minus b whole square equals to r square. Okay, this is equation of a circle in 2 dimension. Now in 3 dimension, it becomes a sphere. Now the center of the sphere is ABC and radius r. Now this is the center ABC, so this is the origin. You will go A unit along the x-axis, B unit along the y-axis and C unit along the z-axis. So this is A, B, C, and this is the radius of the sphere. So the standard equation of the sphere with radius r and center at ABC is x minus a whole square plus y minus b whole square plus z minus c whole square equals to r square. So there is a similarity between this one and that one. Now, to solve this problem, let's consider equation of a circle, center at 0, 0 with radius 2. So here we can rewrite y as plus minus square root of 4 minus x square. Now, if you consider the plus sign, then you will get this equation, and if you consider minus sign, then you will get this equation. Now, this equation represents the half circle which is above the x-axis. Okay, so this represents half circle which is above the x-axis. Similarly, this one represents the half circle which is below the x-axis. Okay, this is below the x-axis. Now, in our example, this is equation of a sphere with center at 0, 0 and radius 2. So this one we can rewrite as z equals to plus minus square root of 4 minus x square minus y square. Now, if you consider the plus sign, then you will get this equation, and if you consider the minus sign, you will get this equation. Now, this equation represents the top half of the sphere. Okay, this represents the top half of the sphere. Similarly, this equation represents the bottom half of the sphere. Okay, so this represents the bottom half of the sphere. Now, in this example, we need to find the center and radius of the sphere whose equation is given by this. Now, here we have 3x square, but there is no more x term, so just write 3x square. We have 3y square, so 3y square. We also have 6y, so take it in left side, so negative 6y. We have 3z square and also have 12z, so take it on left side, it becomes negative 12z. So factor out 3 from here, then it becomes this. Factor out 3 from here, it becomes this. Now, if you do completing square here, then you will get this one. Now, if you multiply 3 and 1, you get 3, which is extra term here. So to neutralize, what we will do, we write 3 on the right side. Similarly, here 4 is the extra term, and if you multiply 3 times 4, which is 12, so this 12 is the extra term, and to neutralize, we write 12 on the right side. Now, this 3 x square, so x square can be written as x minus 0 whole square, and this one, if you apply this formula, it becomes y minus 1 whole square. Similarly, this one becomes 3 times z minus 2 whole square, and this one is 25. Now, if you divide both sides by 3, then you will get this equation, and this is r square. So what would be r? R would be square root of 25 over 3, which is 5 over square root of 3. So this is the standard form of the sphere, center at 0, 1, 2 and radius 5 over square root of 3. Now, for the next example, we need to find an equation for the sphere where one of its diameter has endpoints at 2, 1, 4 and 4, 3, 10. Now, if you consider a circle, and suppose this is the diameter, and this point is 2 1 and this point is 4 3. Then which one would be its center? Center would be the midpoint of this diameter. Similarly, for this sphere, the center would be midpoint of these 2 points. So if you find the midpoint, you will get 3 2 7. So this is the center of the sphere. Now to find the radius. Radius is the distance between center and any point on the circumference of the circle. So for the sphere, this point is on the sphere and this is the center. So if you find their distance, that would be the radius. So radius is square root of 11. So we got center as 3 2 7 and radius square root of 11. Now if you write in standard form, so this is the standard form, then we will get this equation. Now for the next problem, x plus y equals to 2, this one represents a straight line in two dimension, and in 3 dimension this represents a plane. Okay, this represents a plane which passes through the point 2 0 0. This is the point 2 0 0 and this is the point 0 2 0, and this plane is parallel to the z-axis. Okay, now in our next problem, if you consider yz plane and suppose you have a circle with radius 4, then what would be its equation? Its equation would be y square plus z square equals to 4 square. That means y square plus z square equals to 16. So this one defines a circle with radius 4 on the yz plane. Okay, on the yz plane and a cylinder in 3 dimension. So if you consider a circle here, another circle here, another circle here, that means you have infinite number of circles and it represents a cylinder in 3 dimension. And for this example, we have x square plus y square equals to 1 and z varies from 0 to 2. So x square plus y square equals to 1 defines a circle on the xy plane, and since z varies from 0 to 2, so it would be a cylinder of height 2. Okay, so this is a cylinder of height 2. Now for the last problem for today's lecture, the equation z equals to cosine y, where y varies from negative pi to positive pi and x varies from 0 to 2, defines a part of a cylindrical surface in 3 dimension. So this defines a cylindrical surface, this type of cylindrical surface in 3 dimension. Now if you consider y equal to cosine x, the graph of y equals to cosine x between negative pi to positive pi, then it graph is like this. Okay, so in 3 dimension system, it would be a cylindrical surface and shape would be this type, same. So in next lecture we will discuss more. So stay safe. See you next time.